Hello and welcome to ICS Arabia again. Um my guest Andre Froneman for the second time. I'm happy to have him, and we had a really wonderful episode last time about the pharmaceutical industry. Today we're gonna have something totally different. I've never covered before. It's about the automotive industry. South Africa seems. I was just told by Andre is popular of having car makers and those factories. So let's find out about it. Welcome, Andre, again. Nice to see you.
Dr. Suleiman, it's such a privilege to be on the call with you again. Thank you so much for the opportunity.
Sure, it's my pleasure again. So we're gonna jump to the topic straight away because we've already introduced you in the last episode when we talked about pharmaceutical. So why don't you tell us about the automotive industry in South Africa? I didn't know that South Africa is popular or has this industry. So tell us about it, please.
Absolutely, Dr. Solomon. So South Africa has a very unique industry in automotive. I stay in the Eastern Cape. We call it the Little Detroit for good reason. We've got Volkswagen, we've got BAYAC, we've got so many of the automotive OEMs sitting in our territory. And I mean, if we look at the amount of companies actually operating within South Africa between Johannesburg and maybe Durban and the Eastern Cape, it's Volkswagen, it's Ford, it's BMW, it's Mercedes-Benz, it's Mahindra, it's Isuzu, it's Nissan, it's Toyota, it's BAYAC, it's BYD. And there's lots of investment coming from Europe, like Stellantis. There's lots of investment coming from APAC to build manufacturing capability within South Africa. Now, these are all from massive assemblers, right? That does everything from components, they do just-in-time manufacturing where they put the components, everything together, to knock-off plants where they just, put the chassis and the engine and everything together and they let them go. We have some manufacturing capability in Rwanda and Nigeria. I'm not sure about Ethiopia and Morocco on the Northern Africa component. But South Africa has a very robust supply chain from components as well. So we had Bridgestone, we've got Continental, we've got Goodyear, we've got Bentley, we've got Eberspacher, the guys doing all of the components that need to be put into the car. They are actually manufactured here as well, a lot of it, right? So with the tariffs that are coming from Trump, we see a lot of this pressure that's happening, right? Because some of the components come from Europe, some of the components come from America, some of the components are locally made, some of the components come from the East. So the car industry is a little bit in flux currently, but it's a very robust contributor to GDP in South Africa.
Oh, okay. I mean, since when? I mean, the car industry started was it a long time ago?
Yeah, I mean, even during apartheid in the 1950s, I think it's we've had some companies operating since then. Then when the sanctions hit South Africa, during the 70s and the 80s, some of them left, and a majority of them, when we became a open nation, actually came back. So we've got a very rich history in manufacturing, but it was a little bit difficult in the past, and now we also have a lot of constraint. We have constraints on power. Just a few years ago, we had rolling blackouts every single day for years, for 6-7 years. We have some constraints when it comes to putting the vehicles on trains and then the harbors. Because it's state-owned, it's not really that efficient, and it's been dilapidated over the past few years. So even if you build the car, it's kind of difficult to get it outside of the country, But we've got a very nice market in South Africa, a very nice market in Africa, and then we service the European, the American, and the APAC region with the vehicles that we manufacture locally.
Wow, interesting. So, I mean, where you live, you have factories as well. So you said in South Africa, you manufacture some components. So,
correct, absolutely, yeah.
So let's visit a factory now, me and you, and please tell me, what can we see inside when we get to a factory that manufactures components? Do we see PLCs, SCADA, HMIs? What do you see from OT perspective, automation perspective?
Absolutely. Right. I mean, so the first thing that we have to consider is that the automotive industry for an OT specialist is quite an easy environment to work in. Most of the time, the working environment is not as dangerous or dirty as you would have maybe in mining or as you might have in processing and other industries, right? So if I can take an example, some of our customers in the Eastern Cape, if you walk into the factory, it's climate controlled, right? And you see the robots and you see the all of the machines operating in a very convenient environment, right? So for OT specialists and for process engineers, I think it's a quite nice environment to work in. When we go into these environments, the first thing that we notice is you've got a whole region of different isolated areas, right? You've got press shop, you've got body shop, you've got paint shop, you've got assembly, you've got final assembly, you've got the just-in-time warehouse, you've got innovation and R&D. These OT cells are then divided into sub-cells. So maybe in press shop, you've got 3 different machines, and not all of those engineering workstations and PLCs speak to each other, right? So it's a cell within a cell. These factories normally have very high ceilings, right? So when it comes to cabling a robot or a PLC, it's not as simple as just taking a cable under the ground and moving it. Sometimes it has to go 50 meters up, and then it needs to go to a distribution switch of some sort, right? Okay. If we look at what we see inside these environments, we normally see Siemens PLCs. We normally see Hirschman, Rockwell, or Cisco industrial networks. We see Fanuc and we see KUKA robots, lots of those. And we see a lot of visual and thermal inspection capabilities. So we spoke about the cameras the last time, but it's basically using cameras to make sure that the quality of the product or the quality of the process is monitored real time, right? The way that you would build a car is you would put it together section by section by section by section by section. So if you miss a quality issue upstream, you might not notice this quality or safety issue even after the car's actually been built. So it's very important that these OEMs have that real-time visibility around making sure. There's, of course, people that do the inspections as well, but to supplement or complement that as much as possible with visual or thermal. Then these factories have historians, normally running a Viva historian of some sort. They've got some condition monitoring platforms. They've got predictive maintenance platforms. They are busy trying to electrify fleet, which means the products that they are currently selling is internal combustion, and the world is saying we want EV, right? So that's when I was going to the factory, I see a lot of the manufacturing lines being changed, retooled, or another line added to be able to do that, you know. But that's kind of what I see when I go into one of these factories. You've got panels, engineering workstations, you've got the HMIs, a lot of HMIs for integration, a lot of Fanuc and a lot of robots doing a lot of work. So yeah, that's kind of like the average look of it.
So you said they are isolated, there are cells, okay? So are we talking here that there are different zones in the network architecture?
Yeah, and this is not because the customer wanted to comply with IEC 62443. It's purely because the way that these segments were built, the guy that manages that segment wants full control over all of these engineering workstations, of all these robots, of everything in that cell, right? So he then doesn't want his data to move anywhere else unless it's mandated by Europe, say it's a European company, that they want to be able to dial in for telemetry, or maybe the data center. But it's not because of compliance that they are built in different cells. It's because of legacy, really.
Okay, legacy. So tell us about the telemetry. Do you mean that the factory connects to your factory, or correct me if I'm wrong?
Look, I mean, it's really different for customers based on how long the factory has been operating, and also where shareholding comes from. If it's an American company or if it's a European company, then data telemetry has been a hot topic for the last 5 or 6 years, right? So IT guys and OT guys have been struggling to see how do we get that telemetry out of that process network safely, securely. And that's been going on for about 4 or 5 years. When it's a Chinese company, right, they would build the plant and digitize as much as it can, goes to a cloud directly, right? So it's really different compared to where the shareholding comes from. But really getting that data out does one of two things, right? A lot of these customers have to comply with South African compliance. So we've got a Critical Infrastructure Act, and automotive is part of that. They want to comply with NIST 800 or IEC 62443. And then if you're European, most of the big auto OEMs have their own version of shop floor compliance, which looks like 62443, but it's really modified for automotive. Right? So you'll have the same controls. You'll have roles and responsibility. You'll have awareness training, asset management, zoning, conduiting, component hardening, user access control, remote access, availability. You've got very similar controls, but the way that they measure the maturity level is a little bit modified for automotive. You know, so that I think is quite important things, because when you want to get the telemetry out of that specific OT cell, where does it go? Does it go to the customer's data center? Does it go to the Siemens cloud? Does it go to Aviva cloud? Does it go to European cloud? That's a question mark, and it's different for most of these technologies, you know.
And do you, as a OT security practitioner, do you interfere with this telemetry, or do you leave it as it is? Like, do you have to secure it or do something about it?
Yeah, look, I mean, so there's 3 points on this topic. The first thing is, are you relying on traditional OEM telemetry? That means the Fanuc robot is busy doing work. It's got a robotics controller. We could probably have a technology, a management technology for that Fanuc robot. That would be in the data center, right? So that would be a OEM-based telemetry that would come from OT cell, right, to the customer data center. Then you've got third-party telemetry. Now I'm putting a visual camera, I'm putting a heat sensor, I'm putting a dust sensor, I'm putting some kind of telemetry which is not related to the physical robot, but it's related to the physical process around the robot. And then IoT devices are normally either internet connected or very bespoke, might be LoRaWAN, might be Wi-Fi. Not a lot of times it's cable, but that's a different problem. You know, the OEM is one problem, the IoT is another problem. And then there's the historian, right? The historian has traditionally been pulling data from that area, but the historian doesn't sit in the data center. That sits in a server inside the OT cell. You know? Yeah. So that responsibility is different from the IT team to the process team normally. But yeah, getting the telemetry out could either be one way. We focus a lot on secure remote access to enable engineers to be able to But if you want to get data out, normally we can enable one-way traffic to be able to move out of that data center. Now, the issues we have there is data in transit, data loss, and obviously if someone does industrial espionage or they want to steal secrets from the company, that's where this data transmission becomes a really big issue. The other thing that we have to be worried about is if the work order for that specific vehicle has an end customer or a user attached to it, now you've got GDPR, now you've got biocompliance that's also attached to that, right? So that becomes complex. The other thing that is also really complex in automotive is SAP. Right? Customers say to us, listen, I don't like cloud. I don't want any cloud. Then I ask him two questions. Do you have 365 and are you running SAP? Because those two are all being migrated to cloud, of course, you see. And SAP is, I don't know, the Range Rover exploit that happened over the last 3 weeks. That was a SAP outage that caused their production lines to come down. So you don't just have to attack the robots or the PLCs or the engineering workstations. You can attack SAP, which is in the cloud, which is a big problem when it comes to getting data in and out of the production line. Normally, data in consists of a SAP work order, which is printed out. They still print it out, and then the work order happens. But getting the data from the OT cells into SAP is a different issue, you know?
Okay. What about the network there? Is it segmented? Is it flat normally in most of those factories? Or?
So this is a difficult question because I've gone into smaller component supply customers, right? And they have flat network. Maybe last year, the year before, they bought a Fortinet industrial firewall just to segregate IT from OT. So they haven't gone on the journey of conduiting and zoning as yet. They're looking at it now, right? And some of them were forced because they were hacked. Some of them have to follow Datacentrix compliance, which is a automotive standard that they need to comply with if they want to sell to the big OEMs, and that's forcing their hand to basically segregate. Some customers are fully running on zones. Conduits is well defined between zones. Remote access is super locked down, super defined. With session recording, session joining, password obfuscation, asset obfuscation, very, very advanced. So I guess it differs, towards what customer we are engaging.
Okay. What are the common threats or challenges in the automotive cybersecurity in general?
Look, I think one of the biggest concerns is that South Africa is a global geopolitical playground for the West and for the East to actively exercise their red teaming capabilities, right? This is a well documented, well understood fact, because we see Chinese, we see Russian actors, then we see Western actors all trying to get into these critical segments, right? So stealing data from these automotive customers is a big problem, right? That's a big issue. The second one is ransomware. Of course, people want to make money, and if you hit a factory, they've got a flat network on the OT zone, and you encrypt all of the engineering workstations. People don't do backups of HMIs. People rarely do backups of PLC code. People don't do backups of engineering laptops, right? So ransomware is a really big problem. After that, I think it's market transition is a really big risk. So as customers need to move from internal combustion to electric vehicles, they are allowing different types of suppliers to come into their network, and then so supply chain security is a really big problem. ABB is a really good example, or a bad example, right? When they got hacked, a lot of their customers' user credentials for remote access was put on the dark web, right? So that means you can build a very strong cybersecurity posture for you as a customer. You can enable best practices, or try and enable best practices on all of the integrators, the shop floor operators, the machine builders, and the industrial ICS component suppliers, right? But if one of these guys get hacked, they might have access to your system. Normally, when we work with the customer, us as an integrator, we would get VPN access. So we do non-disclosure, liability documentation, all that. We get VPN access. We get access to a server in the data center. We build our remote access tool, or our OT visibility tool, or our, if we wanted to modernize the historian, we build it in that area. And then we expose that device into that process network for us to be able to do the remote access or the visibility, right? And that's just from my perspective. This happens with multiple contractors, right? And then so if you want to get into that customer network to exploit it or dispense ransomware, then I think using the supply chain is much easier than attacking the customer, because the customer has a very mature SOC. Not a lot of them have OT SOCs, by the way, right? So they only monitor telemetry coming from IT, not from OT. So getting supply chain, I think, is the third biggest thing. So it's industrial espionage, it's ransomware, then it's supply chain, and then the final thing is safety and outages. We've seen that a lot of our customers, when they go down for 3-4 weeks, because restoring the IT components is easy, but normally the ransomware attacks the backups. When it comes to doing PLC backups, it's difficult. Customers use version dog or Octaplant, but they've just been changing their technology. But normally it's a USB key that the guys plug into and they copy the code there, right? Very dangerous. From an engineering workstation perspective and an HMI perspective, people don't do backups of that either. So once that ransomware gets deployed, it's really difficult for you to contact all of your suppliers and even your internal people to be able to restore to a steady state. So data recovery and disaster recovery is not well tested in these automotive process areas, in my view, of course.
Yeah, I mean, we talked about this in the pharmaceutical as well. They don't have backups for PLCs and HMI, he told me. So it's the same in the automotive, it seems. Yes.
Yeah. Look, I mean, it's similar for us in mining. It's similar for us in critical infrastructure. It's just, I think that people are only now aware of the fact that these things are important, right? I mean, before, say in the last 20 years, how many times did you need to restore PLC code? Not much. The PLC runs 15 years, 10 years, and if it fails, then you replace it. It's not like a PC that hangs every 2 hours, But now with attacks and targeted attacks where people can change the PLC and maybe destroy a product, or actually when you want to hack a automotive customer, normally what you would do is you would affect quality. You don't want to kill someone. It's very difficult to kill someone with a robot, because if you go into the factory and you look at the way that they section off the specific robots, you have to be quite, there's so many checks and balances in place for a maintenance technician to get into the area where he can be knocked over or killed. It's very difficult for a hacker to even comprehend that, right? You'll have to hack the cameras to look at the robot and then look at shifts and look at all of these things. It's very impractical. So it's better for them to just do quality modifications. Do something to the process which would ruin the car. That I think is something that they would do. Very targeted, of course. Very easier just to deploy ransomware and encrypt all of the areas,
Oh, okay. You mentioned something interesting. You said don't attack the customer, the automotive factory, because they have a strong SOC team. Do all of them have strong SOC team, or some of them?
Some of them. Look, if I look at our European counterparts and our American counterparts, they have a very strong security operations center capability. The gaps in that is that not a lot of these customers are using telemetry from shop floor, right? For secure remote access and from something like a Cisco CyberVision or Nozomi, Clarity, Dragos. They're not using that telemetry as yet. And the people that are using that telemetry set doesn't identify high-value assets, right? So they only see it as a IT incident response if something happens, right? Whereas it might be critical to the manufacturing process. The operator sitting in America or sitting in India or sitting in wherever doesn't understand that it's linked to a machine which is critical to the process. He just thinks it's a playbook, incident response playbook that he has to follow. Some of the customers that we see from the East don't even monitor the environments, So it's different. It's different, yeah.
So I mean, the SOC team is where the country is. They monitor your factory. That's what you're saying.
Yeah, look, I mean, so mostly American companies have their SOCs in America, their security operations centers, and this is really difficult because of time zones. So if you want to be able to do a red teaming exercise, and I'm not talking around ICS, I'm talking about access control, building management, CCTV. You won't normally do red teaming on ICS directly, but just around the process. It becomes really difficult because the time zones are completely different. It has to happen at night and so forth. When it comes to ticket feedback, and the CISO gets feedback at night where he needs it during the day for his board discussions.
All right, interesting. I mean, so a factory could maybe this one building could have many countries that own something in this factory. Am I right?
Absolutely.
And each country has its own team, like red team or SOC team outside to. So this factory
worst case scenario that is,
every country or client has a piece of this factory that he's responsible for.
Yeah, look, I mean, most automotive customers are not like that. So they would have equipment, and the machine builder might own that specific machine. We do have some automotive customers which rent out manufacturing space. This is really interesting, right? And the Chinese companies are good at that. They have a big factory. On one side of the factory, they would build, I don't want to name, but they would build one brand. Then that company will build another line. It will build another brand and another brand. In that instance, you've got one company that owns the building and one production line. But then there's a different company that owns the second line and a different company that owns the third line. And that becomes quite complex.
Yeah, I mean, do you have to deal with all of this for you as an integrator? You have to deal with all these customers, all these clients.
Yeah. And it's opportunity. It's a good opportunity. So let's take MES system as an example, right?
All right.
The customer already has the existing MES for line number one. Now the second operator comes in. He looks to the factory to say, help me with my PLCs, help me with my network, help me with my MES, or he comes fully kitted, right? One of the two. If he needs help deploying the MES and he needs security posture and compliance with 6443, it's great for me because we get to help them down that journey, you know. But it becomes a very complex thing to monitor because from a liability perspective and a legal perspective, you might not be able to pull SOC telemetry from someone that's your customer effectively.
Okay, so there are different countries managing different lines. I'm sure every country has different cybersecurity or standards or regulations. Do they have to follow the countries? I mean, the factory, the country that's South Africa. Do they have to follow its rules in cybersecurity as well, or they don't?
No, absolutely, they have to. So, if I can take Europe as an example, Europe has UDC 155, UDC 156. They've got GDPR. They've got NIS2. Okay, but that's not too applicable to the manufacturing. But what this means is that not just the manufacturing process needs to be cybersecurity compliant, right? So all of the the engineering workstations need antivirus. There needs to be maybe Active Directory or at least a username. The remote access needs to be well defined. All of these security controls we know quite well. Over and above that, the car needs to be security tested, right? That means all of the components that are supplied onto the vehicle that touches the CAN bus, their components need to be security tested. And this will wrap up into a certificate that gets shipped with the car when it goes to Europe. So not just the manufacturing that's affected, but also the actual product.
Oh, okay. Yeah, this is quite interesting. I mean, different countries in one building share the same factory.
Yeah. Look, there's one in Eastern Cape that does that. One company. And it's interesting. Like you say, I haven't seen this anywhere else in Europe or America as yet.
Yeah, we don't have this common also in Kuwait. I mean, so every line you look at it has different cybersecurity practices than line 2, level line 3, and you have to deal with them all. So
yeah, luckily in this case, all three of them are from China, so that might make it a little bit easier. You know, if it was one from Europe, one from America, one from China, one from India, it might have been a little bit difficult.
Wow, that's interesting. Okay, so you said don't try to attack the SOC team because don't attack the customer because they have good stock. Just the best way is to attack the supply chain. Who do you mean by the supply chain? Do you mean the integrators, the contractors? Who do you mean?
So supply chain in this instance is upstream and downstream. Downstream is all of the car dealerships, right? So if you go to any car dealer and you ask them who the IT guy is, he's going to say, oh, that salesman over there is the IT guy. Right? Because they've got a access point, a CPE, right? And they've got a bunch of laptops, and these laptops are used for personal things, for whatever it depends on the maturity of the dealership. But these laptops go directly into the customer's network for parts ordering, for stock availability, for color ordering, for these things, right? And these spaces are normally in a DMZ. It works on FTP, which is highly encrypted, but there's still a way in, right? So that's southbound. The northbound supply chain are all of the people that have existing equipment on the plant that needs to be monitored. Could be a Siemens, could be a Rockwell, could be a Festo, could be whatever these guys are. It could be an integrator like me, right? It could be a machine builder or a shop floor operator, like guys that are managing building new machines on the process line, right? Or it could be security providers, right? Or it might be auditors, people that have to remotely come in and do audits, right? Or it could be software suppliers, right? When software supplied, like we saw with SolarWinds, effectively, right? Or it could be cloud providers. A lot of exploits happening is actually on the cloud side,
Okay, so it's quite a big list of supply chain. I mean, for one factory. And do you have
also? Sorry, Dr. Solomon. I also wanted to tell you that not just getting in from supply chain, but actually hacking and stopping the supply chain. the way that automotive vehicles are made predominantly is by a process called just-in-time manufacturing.
Yep.
That means the spare parts converge into a single area just in time for the manufacturing of that vehicle to be assembled, and it goes. So if a hacker is smart, and they would look and see, okay, which one of these supply chain customers, is it tires, is it dashboard, is it engine, is it seats, whatever the case might be, would have the biggest impact in stopping the process of the automotive customer, right?
Nice.
So when you hit that guy with ransomware, you can say you can ask ransomware from the OEM, and you can ask ransomware from the supply chain. Now, sometimes these automotive have a very, very advanced method of sourcing, right? So sometimes they would have a source for one device, and then there might be an alternative for another device. Unfortunately, South Africa has been, we lost 300,000 jobs in the first 3 months of this year, right? So a lot of these smaller component supply chain companies have closed down, and it's more difficult for these OEMs to get parts. So a hacker could effectively look at one of these high impact supply chain, hack them, and this would disrupt. And normally these guys support more than one OEM. They would sell to a Volkswagen, they would sell to a Ford, they would sell to a Toyota. So if you hit them, it could have a cascade effect to the big OEMs, you know? So not just use them to get in, but also use them to stop production.
Wow. This is interesting. I mean, and do you have, do you as a OTC cybersecurity, your job, do you have to check the supply chain normally when you visit a factory? Do you have to ask for it and do something about it, or it depends?
So we're quite lucky in the automotive industry. There's a compliance called TISAX or TISAX, and what this is it's a operational and cybersecurity best practices guideline, and what happens is let's say a Ford would push that TISAX compliance down to all of their supply chain component suppliers, right? So that means if you sell me a tire, you need to have these basic cybersecurity controls in place. So a lot of my work is to do OT cybersecurity assessments at the big OEMs, but also at the smaller guys to help them get TISAX compliance.
So it's called T6?
Yes.
T6, yeah, Trusted Information Security Assessment Exchange.
Correct.
And
that means,
yeah,
that means if you want to be able to trade with me, your cybersecurity posture needs to be under control. That's what the program allows from an OEM to a component supplier.
So all those OEMs and all those lines, they have to be compliant first before they join.
Correct.
The factory.
And
yes.
they on TISAX version 6 now already. So this has been going on for a few years. But I still get customers that call me and say, "Come do a OT cybersecurity assessment. You know, go put a cyber vision probe down and scan for assets and look for end of life, end of support, vulnerable firmware, all these things." They still ask me to do these things in support of TISAX compliance.
TISAX, okay. So do you think TISAX is similar to 6.2?
No. So TISAX doesn't have as many controls as 62443. Right? If you look at the automotive industry, they've taken TISAX and modified it for automotive. There's about 24 controls, right? And these are things that would be very familiar to you. It will be user access control. It will be remote access, conduiting, zoning, all of these things, right? But TISAX is a high-level guidance document, right? So it says your doors must be locked, your data center must be locked, your switches must have default credentials removed. It's very basic. It's not. I don't think I can compare it. 62443 is a really good standard for shop floor, so I don't think I can compare the two.
So TISAX is commonly used in the car industry, the automotive
industry, yes. Yeah.
Okay. It's not used in the pharmaceutical or.
No, very specific to the auto industry.
Car. Interesting. All right. What you just mentioned that the car automotive industries, they have robots as well.
Yeah.
And were they responsible to make some people lose their jobs, or in the automotive industry, or because you mentioned 300,000 were they lost their jobs, right, in the automotive industry, or what?
No, this is in South Africa in general.
South Africa.
Yeah, look, let me tell you, we already have seen big companies exit South Africa because of the tariffs and because of electricity prices being high. Our labor costs are also now not competitive anymore. Our labor cost traditionally was really attractive 5 years, 10 years ago, right? But that's coming. As we modernize South Africa, that's kind of it's coming out of that trend. But fundamentally, if you look at downsizing and then you go look at the customer's financial statements and you look at the financial return, you would see that digitization and robotification, if I can call it that, plays a
Okay.
very big role in automotive, right? Traditionally, the robots used to do welding, right? They used to do stamping. They used to do some kind of press. They move from one area to another area. That has been going on for some time. Where we see a massive innovation happening now is in the logistics component. Automated robots connected over Wi-Fi, which take stock from one area to another area. That's a hot topic. For DHL, for Schneider, for all of the big guys are automating that component, that just-in-time, manufacturing, the robots, the fleet that goes along with that. Then, of course, as equipment becomes more modernized, the robots have become stronger, more reach, better angle. It's possible to do more of these things, and from a painting perspective, robots are there. From as I said, from a welding and from press and from a move and from a legit, robots already there. And I don't know if you've seen the dark factories in China. There's factories in China that build the BYD vehicles are completely dark. There's no people in them. The whole process.
Yeah, I've seen it. Yes.
Yeah.
Yes.
And that if you're a CEO of a company, social development is really important, right? But profitability is more important. You need to be able to build a vehicle at a certain price range for you to be able to sell or to still be alive. So we'll see this digitization and adding of robots become much more prevalent in the market, much more. We have a very robust robot competence in South Africa. So we've got big companies. We got guys doing Fanuc, we've got guys doing Kuka, and they're really good at what they do. They've got the specialists, they've got the process engineers, they've got that the engineers that are very specific to maybe the paint or the welding capability. And that's quite a mature market for us in South Africa. Our robot technology is quite good.
Yes. Do you think doing OT cybersecurity in the automotive industry is exciting and fun? Do you like
Absolutely.
it?
Absolutely. Look. So from my perspective, it's quite exciting to think that I'm going to run Nmap and I'm going to run Metasploit on a car, right? So it's so diverse that if you look at the factory, you look at CCTV, you look at access control, you look at building management, you look at shop floor printers, shop floor scanners, you look at smart tools, you look at the robots, you look at the PLCs, engineering workstations. There's so many things for you to consider. It's a really big mental challenge. But let me give you a simple example of water, right? Every automotive assembler that has a paint shop has a massive water requirement, right? And then water treatment is not something you would consider a cybersecurity target as such, right?
Yeah.
But if there's no water, paint shop doesn't work, right?
Yes.
And we know very well what devices are in a water treatment plant because we service all the water treatment in South Africa, right? So for a hacker or for someone to exploit that, it's not going to be really difficult, So the reason I like it is because you get to do security for shop floor, the IC security, but eventually as cars become smarter and they're going to be fully autonomous and they're going to be fully electric, then the cybersecurity in the factory and the cybersecurity on the product are going to be just as important. We haven't even spoken about charging stations. A lot of the work we do is securing charging stations in South Africa, making sure we do SSL certificate management, making sure the field bus devices are secure. There's a lot of stuff sitting in that area which doesn't fall under the automotive OEM, but it's very important for us to be able to grow our electrical industry.
You mean charging stations for the electric cars?
Yes. Yeah.
And have you dealt with them?
Absolutely. So I'm quite lucky. The company that I worked for was part of a group, and the biggest electrical operator in South Africa was part of that group. Companies called Grid Cars.
Right.
So we learned a lot about how they were deployed, what the machines looked like, how they engage with the financial system, how they engage with the vehicle with the tag. What security concerns do you have when you plug it in, right? If there's ransomware
Yeah,
on the
okay.
charging station, can it get into the car? So we've learned a lot around that infrastructure. And I think that's going to be an area of focus in the next few years. BYD is coming here, and they're going to add 1 gigawatt of charging station capability in the next 5 years.
I've never heard or read about charging stations security. What are the security risks?
Okay, so the first thing is charging stations are either connected on GSM, right?
Oh, okay.
Sometimes they are connected to a fuel stations network, right? So immediately there's a connectivity entry point, either man in the middle or disruption, denial of service, right? And this has become a big issue. If you do a denial of service on a certain charging station for maybe 1 day, 2 day, 3 day, 4 day, users don't use that charging station anymore. And all of the revenue from that charging station is lost to the operator. That's the one thing. The second thing is the integration from the vehicle to the charging station, right? So 1 day, maybe theoretically, you'll be able to get from the car into the charging station network, or from the charging station network into the vehicle, right? There's some security protocols that they've got in place, but maybe this is something that will be exploited in the future. The third thing is the financial integration, right? That means as the tag or as the fuel happens, there's integration between the charging station, the charging operator, and a financial organization, right? And all of this is exploitable. As I mentioned, supply chain, right?
Interesting.
If you can't get the one, take the other one or do the other one. Then the final component is support, right? If the vehicle is standing and he can't get electricity, he gets on the phone with the operator, and then the guy logs in remotely. So there's a whole support call center which can be exploited. Very easy. I call as the customer, I say my card was lost, give me the guy's details, and I can extract private information from these guys, or maybe even get a free charge. There's some issues there. So I see those are the 4 levels of security that I can think of.
Does it include a software, firmware? I mean, does it have an operating system? Those charging stations that somebody can connect to?
No. It's normally a firmware or some Linux very low code
embedded.
Linux environment. Yeah.
There's embedded.
But because but because it has to be able to speak to the web, and because it's got to be able to speak to the internet, to a cloud provider, and because it has to be able to speak to the financial application, there's exploitable areas even in that.
So if you are managing them in the cloud, you can see how many charging stations you have in particular area, and you can know the diagnostics and everything of this charging station.
Absolutely.
If you're the admin, for example.
Yeah, look, and charging stations are a very low margin business. Yeah, people think they make lots of money, but the security of the electrical prices in South Africa has become quite high, and therefore it's a low margin business per charge. You almost pay the same amount of money for a full charge than you do for a full tank of petrol. So the charge operators are not cash flush. They can't put an antivirus on every single charging station. That would throw the financials out. So it makes them very difficult to secure their infrastructure.
You just opened the topic that's very interesting. I heard about it in 2014. It's about hacking cars. And there were some talks in Black Hat and DEF CON about how to hack cars. I mean, using the protocols they use. And they use some chipset to open the car, switch on the car. And sometimes they are connected to the internet. Have you dealt with something like this or not yet? Like,
look, we are having very active discussions with our OEMs because of the UNIC 155 and 156 regulation in Europe. This pen testing of the vehicles will become mandatory in a given time. Getting that skill set is really difficult. South Africa's unemployment rate is almost at 40%, right? So it's very difficult for you to find ICS and OT resources. But I mean, from a vehicle perspective, you've got infotainment, you've got Bluetooth, right? Then you've got the fob that is exploitable, and then you can connect directly to the CAN bus and exploit the vehicle that way, right? There's widgets to do that. But that's not mandatory yet, and very difficult for you to find skill set in that area. But this will become a very hot topic. In electric cars, it's much easier, right? There's many more access points. On some BMWs and Mercedes Benzes that has the built-in SIM cards, it's even easier. But most of the times, these units in the vehicle are segregated. I mean, they had that video about the Jeep where they came in through the infotainment. The car was driving behind the Jeep. They hacked into infotainment and they could lock the brakes on both sides, right? I think that was they must have had the code, or they must have had the programming for the CAN bus, because what we normally see is that these are segments of operational area on the CAN bus. For you to be able to get to the brakes is really difficult if you're coming through infotainment, right? Because it's normally segregated like an OT cell would be, or like a containerized areas, But this is a very interesting topic. There's been some good work done on exploiting vehicles, and stealing vehicles in South Africa is a big thing. We use what they would do is they would take say you leave your car keys in the front of your house. One guy would walk to the front of your house at the front of the door with a big aerial, and the other guy would be standing with a fake key at the car, get in the car, open it, and just drive away, right? Because it extends the signal from the fob into the car. That's people do it a lot in South Africa.
Yeah, it's common. I've seen this in some videos. And like you said, the car hacking or pen testing is very hot. And I think it will be started already, but it will be more in the future.
Yeah.
Because
because
most of the cars are going this direction. They're going to the direction of smart car, internet connected, managed through application, so it is going this direction, I'm sure.
Yeah, absolutely. And then so when we talk around safety systems in the plant area, right, that's quite an important thing that I don't think a lot of ICS engineers actually consider. When you want to protect the plant, you normally protect the process network, not the safety network. Now, the vehicles are going to be the same, right? You've got a safety standard on the vehicle, and that safety standard says that you must drive this slow, this far, and if it's autonomous, there's lots of rules and regulations. But we don't normally look at that safety system from a cybersecurity perspective, and that I think is going to be something that needs to be looked at.
Cool. So it looks like the car is turning to be an OT system.
Exactly. You're right.
It has a safety, it has control, it has a protocol, it has dashboard like the HMI, whatever.
Yeah, exactly. And I think the weak point for vehicle hacking is the cell phone, effectively, right? You can use Pegasus to get into anyone's cell phone, and normally your cell phone's connected to the vehicle. So you don't have to be in proximity of the vehicle. You don't have to hack the charging stations to get into the vehicle. The user's the biggest entry point, I guess. And so cell phones, I think, is going to be the weak point, because that cell phone integration makes life easier, makes for navigation, makes for all of these things that we enjoy as we are comfort creatures,
Yep. So, I mean, when you talked about, with the manufacturers about securing the cars and pen testing the cars, what were their response? Were they positive about it, or will they consider it?
Yeah, the European OEMs already have divisions in Europe which are actively looking at securing vehicles. This is CAN bus level, this is code level, this is infotainment level, this is fob level, Bluetooth level, GSM level, at all levels. Right. Some of our suppliers which are just selling to Africa, they don't care. Right? In Africa, cybersecurity for vehicles is not a big thing, because South Africa will have a big problem with autonomous vehicles. Right? Adoption is going to be really difficult. We are the most violent country in, almost on earth. So if you have autonomous vehicle, the first issue is getting electricity, because we've got electricity problems. The second thing, if someone wants to steal your money, they just walk in front of the autonomous vehicle. The vehicle has to brake. It's lawfully, the vehicle has to do that, right? So it's basically a death trap, because most people, when they get robbed, they get killed as well. So if you have an autonomous vehicle, you have no control over that situation, and threat actors will take full advantage of that, physical threat actors. So autonomous adoption in South Africa, I think, is going to be a really difficult thing until crime gets under control.
Got it. Got it.
Yeah.
Some factories are going to be smart factories. Do the automotive factories are going this direction in South Africa or not yet?
Absolutely, they are. So there's lots of processes which are driving this. I think ESG or carbon reporting is a big one, right? Because when you sell your vehicles to Europe, we've got something called the carbon border adjustment tax. And because 90% of our energy in South Africa is made out of coal, you have to be very accurate in the way that you predict your carbon from a waste and a procurement and a supply chain perspective, right? So that ESG component from a factory is important. Now, our business is quite involved to put electrical metering and ESG software from Invisi in to help customers to get Scope 1, Scope 2, Scope 3 compliance in their manufacturing methodology. But that's driving electrical digital process. The second thing that's driving digitization is cost pressures, right? So it's really difficult for customers to understand how they can optimize costs if they don't have that telemetry from the shop floor. And then the third thing, which is really important, is the products that need to be modernized, right? Internal combustion vehicles need to change into electric vehicles. So it's a perfect time to make sure that every single asset, every single robot is connected to that process network for telemetry, right? So those are the three things. It's ESG, right? It's looking at different electrification methods from a vehicle perspective, and that's really to get your cost under control. Those things are driving the digital factory in automotive in South Africa. Some customers are quite advanced during that process. Some of them are just starting the journey, but at a board level, this is definitely something that's discussed at every single OEM and component supply chain customer.
Interesting. So, I mean, you like automotive cybersecurity. What were the most common controls that you have implemented in this industry?
62443, I think by far is the most common framework that we work towards. Secure remote access, I think, is the biggest feature to support the controls that we work on. And this is really fundamentally, when we talk about remote access, this is not just remote access from the outside world. This is access to the process network from IT, access to the process network from cloud, access to the process network from the office, access to from anywhere, right? So it's getting into that area. And this needs to be, it has to have session recording. It needs to have multi-factor authentication. It needs to have all of these best practices. So you've got identity and you match identity with a device, right? And we also, what we would like to do is to remove usernames and passwords directly from users. A user must log in with Active Directory credentials, and he mustn't know what the PLC's username or password is, right? We go to customers, they've got an engineering workstation, and there's a file on the engineering workstation that says password.txt, and it's got all of the TIA Portal, and it's got all of the passwords in there. We don't want that. We want to be able to have like a little web browser, and the engineer clicks on TIA Portal, and it just opens TIA Portal over the web, right? Or through SSH if it's an industrial switch. That's where we want to get. But remote access is the one. And then OT visibility is probably the second biggest one. We deploy like Nozomi or CyberVision or whatever that. We don't really care about the technology. We do pretty much all of it. I think I've got my Nozomi shirt on, so they'll probably not like the fact that I've spoken about. But really putting down a device inside that process network that gives a view of all of the assets. It tells you if your PLCs are end of life, if it's end of support, if it's vulnerable firmware, how they communicate to each other. That, I think, is our second biggest service that we take to market. And then the third biggest one is the ESG, is like the electrical metering that we do.
All right. This I don't hear often, the third one. Could you tell us more about it, please?
Yeah, look, so as I said, the Americans have become anti-woke. And they've also put big tariffs on us, right? So Mercedes-Benz is closing shop, Goodyear is closing shop. But our European market, right, still wants us to report on ESG, right? And so environmental, social, and governance. Now, from a governance perspective, our customers are doing great. From a social perspective, they're all investing in Black economic empowerment and all of the social programs that they have to, right? But from a ecological perspective or environmental perspective, that's where we focus on. And that basically, that means that when you get financing from Europe to build a new manufacturing plant or to upgrade your manufacturing plant, or if you sell to Europe, they would expect you to declare your carbon footprint and declare your carbon plan in your financial statements before they do business with you, right? So it's become very important that your ESG strategy and implementation on the shop floor is done nice and correct in support of selling equipment or cars into Europe.
Yeah, but how this is related to cybersecurity control?
Oh, it's a very big entry point for risk, because all of these IoT devices that they put in for electrical metering are normally cloud-based, right? And then also, I mean, from an OT perspective, we work a lot on electrical systems. You know, people don't secure electrical systems. Most of my automotive customers own a substation because the government doesn't, you know, maintain it, doesn't do anything, and it's been standing for 30 years with no upgrades. So electrical management, substation wise, and electrical management in the factory is very much overlooked by cybersecurity professionals. So we see that as a good management point. If we deploy that technology for the customer, they've got cost containment, but all of the cybersecurity best practices is baked into the offering that we take into that environment.
So, I mean, applying the best practices cybersecurity to this machine or this environment is crucial for the ESG.
Absolutely. It's crucial for ESG, and it's also crucial for cybersecurity on the shop floor. You know, because if you think about it, when you pull telemetry, we spoke about the SOC a little bit earlier, right? You've got an IT SOC. Now you've got what is the OT SOC, right? I think OT SOC is an environment where we pull telemetry from Nozomi, we pull telemetry from Siemens, we pull telemetry from KUKA, we pull telemetry from all the robots, all the machines. We have it in an area, but we put all of the high value assets so that the operator can understand this is a robot. He can understand this is part of the process. He knows who the process engineer is. He knows who the shift manager is. He understands that if something goes wrong, he doesn't just call the security people, he calls the operators as well, right? But fundamentally, if you take telemetry from the OT devices, and you take telemetry from the electrical devices, and you take telemetry from the remote access sessions that I also sell, then your OT SOC has a very, very wide view of things happening in that factory, right? It gives you two blind spots, which other integrators I don't think about a lot. That is the electrical side, and that's the remote access side, telemetry that goes into the SOC. So that's why we focus on that quite a lot. You know, we get involved in areas of ICS that really dictates the way that the customer can sell product, right? Make it cheaper, make it faster, make it better. And then so that's why these things like ESG are also on our radar, right? We have to make the manufacturing process more visible. We have to make it more resilient. We have to make it more restorable, and we have to make it more green. And all of these things play into what we do as an organization.
Wow. I mean, considering in green in your field, I mean, from what you do is a bit uncommon. It's uncommon. It's not very much. What do you think about it? I mean, going green from OT cybersecurity perspective.
Look, I mean, it's for me, it's a massive risk. If you look at what people think of green, for some reason they don't like nuclear, which is very strange. I have some experience in the nuclear industry. I'm a consultant for Moswelli. But if you look at wind and solar generation, most of the equipment that you buy for solar generation, which the automotive have on their rooftops, are Chinese equipment, default credentials, unmanaged, connected to their network, right? So going green comes with a lot of risk if you don't do it right. And that I think for me is very important. When we go to a customer to do an audit, we don't just put a tool in and scan the network, because we know there's PLCs that are not connected to the network. So we have to check them. Then we have to look at all of the security or the electrical appliances that they have. We have to check if they've IP connected, Modbus, FieldNet. Then we go look at the solar inverter, see if it's connected to anything. So this is why green energy could have a really big impact on the automotive manufacturing process. It's an entry point that no one thinks about.
Makes sense now. So you mean making the green works or function as it's supposed to be, and not causing any threats or impacts on the process. That's what makes it successful.
Absolutely.
So you cybersecurity people make sure that the green is really green, even in its effect, not just not just in,
Absolutely.
not just on the got it
Yeah.
now. It's nice,
Yeah.
nice.
Look,
I mean, nice connection
nice
with the.
integration. Yeah. And look, I mean, if you work with manufacturers,
Yeah.
energy quality is a big problem. Energy quality coming from a gas generation, or from coal or from nuclear is nice. Energy coming from wind and solar, from an equipment quality perspective, is also something to consider. So
Yes.
when you look at reliability of PLCs, reliability of engineering workstations and robots, energy quality also plays a big role in that. And then for
Yes.
you to be able to predict if something's going to go wrong, the telemetry that we get from OT cybersecurity could be very helpful to the planning department and to the guys that actually manage the equipment.
Nice, man. This is nice. Nice perspective. I mean, looking at the green from OT cybersecurity professional like you. I think we've come to the end. Anything you would like to say, Andre? That's something we
No,
missed. We didn't talk about.
no. Look,
Maybe.
I think I think I'm happy, Dr. Suleiman. You've covered some very good points. I think the automotive industry has a lot of work to do in the cybersecurity space, the ICS cybersecurity space. Having professionals like yourself that talk about these issues in public will helpfully motivate young, diverse people to apply their minds to ICS security. And it's not an easy job. You have to get your nails dirty, and you have to be at the plant, and you have to work with the asset owners, and you have to. It's heavy lifting, right? It's not an office job. But hopefully, education like you giving to the market will inspire young people to be able to get into this industry and help us support the automotive industry.
Nice. I mean, do you think the automotive industry still needs work to be done in terms of OT security?
Absolutely. I think in South
They-
Africa, OT security is maybe. I mean, I'm going to give my age away. This shirt is from 2013, but
Oh,
but OT security as a practitioner from Deloitte and McKinsey and all of the big operators and the serious integrators, it's 5 years old. Seriously, where people invest in OT engineers and they
agree.
advertise for OT cyber engineers, and process engineers are getting a security KPI, and it's relatively new, so we have lots of work to do. But I think we have we've got strong competence in the few people in South Africa that lead up the space, and hopefully young people will take that up and start investing themselves, understand network, understand processing, understand all of the PLCs, understand all of the controllers. Focus on Rockwell, focus on Siemens, and get a broad holistic view of how cybersecurity applies to all of these devices that we see in the factories.
All right. Do the automotive factory has different components than other than HMI and SCADA? Like, do they have their own lineup machines? That
No,
that
it would be very similar to what you would see in pharma and food and bev. The application is completely different, and the vendors are. I mean, for instance, you won't see a Festo in the automotive industry, right? You'll see ABB, you'll see Bosch, you'll see KUKA, you'll see Fanuc, you'll see Siemens, you'll see Rockwell. But some vendors, even Yokogawa, you would see in there. But it's robots, it's stamping machines, it's welding machines, it's people putting stuff together. Nothing weird or exotic.
Okay, interesting. Thank you, Andre. Really, it's been really fun to talk with you, and thank you for sharing your information and your expertise.
Absolute pleasure,
Anything you
Dr.
would like?
Simon.
Any advice you would like to say before we close up?
No, I'm good. I think very excited about the ICS industry. Lots of growth left. We need more people. We need more expertise. We need more young
Yes.
people to engage. And I'm just happy to be part of it. And thank you, Dr. Suleiman, for the opportunity.
Yeah, thank you, Andre. You're welcome. I'm really glad to have you for the second time, and it won't be the last. I'm sure
Absolutely.
about that. I really had fun talking with you about the pharma industry in the previous episode. So many medical people who worked in the medical industry in Kuwait, they loved it, they shared it, especially between pharmacists in Kuwait. They liked what you said about because it's very, very new in Kuwait. Nobody ever heard about pharmaceutical cybersecurity in my country. So they're really happy and thankful for the information you just shared. I just wanted to tell you that.
I'm very glad.
Yes. Thank you, everyone. I hope you enjoyed the talk about automotive and cars and car hacking. See you next time. Take care.
Thanks, everyone.